Welcome after the break. Let me remind you that we are in the day 2 of the international infraBIM event, Visegrad Group. We have completed a couple of plenary sessions and the discussion panel, and now we are about to start a series of workshops, and the presentations will be a little bit longer, and they also may be a little bit different. And we are going to be delivered in Polish, but you still can use the English translation. The speakers are kindly asked to stay with us online, as the participants may ask questions, and you will be kindly asked to answer the questions which may come. And please remember about the competition on BIM knowledge. The competition will be finished tomorrow, will be completed tomorrow, so this will not be continued anymore. And in this session we have 3 workshops. The first one, Daria Kosmala, a Bentley company. 4D in infrastructure, plan, analyze, visualize. The floor is yours, madam. Welcome, ladies and gentlemen. I am really happy that I can participate in this edition of the event. I have prepared a workshop which concentrates on 4D for infrastructure. The title is Plan, Analyze, Visualize. But I will also be speaking about some more things. My name is Daria Kosmala. I'm a part of Virtual City and a member of Bentley. This is an e-commerce platform. And as a co-author, let me introduce Paweł Krecz, who has also his inputs into this workshop. And that's the Virtual City slide. We are an e-commerce platform, so you can buy software, and my role is to supply trainings which are related with each license, and this is a synchro training. And Paweł now is our partner, training partner, and also sales partner, including in Poland. Let's start with some kind of process. Originally, we have some stages of the project where we concentrate on implementation, and we need to acquire some data, some information about the environment. And in this context, we create a 3D model, 3D BIM. And out of this, or using the model, you can move it to the next dimension. This is a 4D, 5D. And finally, you can use the model in the construction site. So this is a classical BIM. And if the process of planning and designing, so planning of the construction is carried out simultaneously, we can speak about VDC, virtual designing construction, and we are going to have another panel on that. And I will concentrate on this 4D and 5D section, but you still can remember that these things can happen together or simultaneously with the designing phase. So this is a 4D model. There is a schedule of our actions. We also have here our resources, materials, equipment, human resources, and also obviously information on the project itself about the 3D model, so geometrical information, where non-geometrical information is also assigned to. And when we can combine all these 3 components, can more information be added. And the 4D model, that's where we will add some more levels of like status of resources, and this model can be used for some purposes. What the purposes are, let me speak about this a little bit later. So why do we do all these things? And I think this is the most important questions. This is what I start all my meetings with new users. I ask them, why do you want to use the 4D model? Why do they take this decision to start using this technology? And many times people speak about money, but nobody mentions money as the very first thing. But of course, we do this to save money, and also we do this to plan human resources in a better way, to increase the forecastability of what can happen, to be able to analyze things, to improve the quality of our works in the construction site, to decrease burden on the environment, or to decrease generated noise. So what does it look like practically? That's an example of one of the finalists of BIM infrastructure. So this is Clark Construction reconstruction of SeaTac Airport. That's a winner. And this is, let me rewind it. Of course, you can see this in details. But that was all about planning of developing of a pillar and adding one more story, and precasting of a connector length of a football pitch. And this connector was precast on the construction on the airport, but at some distance from this. And we were using laser scanning to see if what we managed to precast is within the tolerance, and we carried out and carried out the construction, also the transport of the pier to affect the airport as little as possible in terms of its operation. And the key moments in time was transportation of this pier through the airport and the constant operation of the airport. And this must have been done once. And finally, this pier was installed, so this is the longest flyover over the airport in operation. There is a taxi ring beneath, and this is a company which has been in this industry of VDC for a long time, also in large-scale facility like stadiums. And now we are again on the ground level. Let's start with some simple things here. Let's start with something very, very simple. We will be speaking about planning, about the analysis and visualization. And with a small font, we've got this word preparation. As before we start doing things, we need to appropriately prepare data. And this preparation phase is of key importance for what we will be able to analyze and how we can work with our schedule with the 4D model or 5D model. What we have, this is geometrical data. These can be native models, 3D models, or CAD models, BIM models. We may also be using IFC models. Probably that's a little bit shortening of things, but we also may have some measurement data or some numeric data. We may have some data from added to mesh grid, and this mesh grid can also be used. And we also have non-geometrical data. We have got some schedules, and they can be generated based on models, but most frequently it is based on and somewhere separately in a scheduling department. So we've got this schedule, and we have bills of materials, information on the resources, and also have the cost, bills of costs. And now, how to import these models? How can they become a part of the 4D model? One of the most common approach is just to directly import those. So from the desktop application level, you can import data, and you can also work on the cloud-based models like CA. Supported file types can be found online. The list is quite long, and you can use plugins. As in the future, you will also be able to synchronize changes for Navy's works. You will be able to use NVF. And this workflow allows you to keep data, also non-geometrical data, in user fish bounds. You can import data directly, so you do not have to use plugins directly. You can do that that's good for equipment which do not need to select separately each aspect. You also can connect these models using synchro control. So you can place them in your cloud, and you will be able to generate a connection to eye level. So you work on collectors, and what is interesting, there is interesting functionality. You will be able to connect meshes and point clouds in context share. You can also create named versions, and you can compare the versions before and after the update. Why do you need to take this decision, and what is the import strategy? Much depends on what you will be able to do on next stages. So the possible connectors are also, we've got quite a long list of those. And as a final result, this linear model can be divided in synchro modeling into individual kilometers. You will be able to keep the data which you need for time calculation. You will be able to calculate volumes. And also, you can add AFC models, and you can improve the locations using the actual coordinates. The model has a specific system, geographical system, added. It has a realistic actual location. You can find it on a map, which can also be used for localizing of issues. And as I have mentioned, if you add meshes, you can overlay for the model on a mesh. And you will be able to compare what is planned with what the conditions on site are available. That's not only true for meshes, but also point clouds. So all these need to have the same geographical reference. There are some quite interesting options available. So if all the history of meshes are connected, you can track the construction progress. It is also an additional communication way with the site, as this cloud-based project is available on mobile devices like Synchrofill. And there is a nice functionality. If you take a photo, there is a functionality of automation category detection, so it will detect what is included in the photo. This will take out the text message, and all those photos can be added as attachments to some issues. They will be localized in a particular place on the map, and this can be used for communication with the site and managing of the photographic documentation, which is usually located somewhere in BIM. And sometimes there are plenty of those, and it is difficult to move about them, and there's not enough time to check what is happening. Very briefly, we have mesh grids which can be used for designing, and these meshes can be connected to the cloud environment. And also from the construction side, you can also connect to Synchro. And again, this documentation can be further used. And another element is connecting to external schedule. And you can connect external and internal schedule. We have quite significant interoperability with other types of software. It allows fully to move data from from this software to Synchro and synchronize later. But as I want to use simple examples, many constructors still use Excel. Let me just describe on how you can move from Excel to Synchro. If you have a model, if you have a schedule in Excel, you can move it to Synchro by, like in Synchro, you will open individual columns which will correspond to data in this schedule. So you can create subcontractors. You will copy the schedule, copy-paste to this template from the Excel sheet, and then you will be able to import this. So if you define a contractor, you can also get this information on who is the contractor here. So if like embankments or trenches, volumes, so you can also do this in Excel. And the same, you will copy and paste. You also can create some resources and import all these to Synchro, and this information will be available for you to use in Synchro. The same is with cost. You can import cost of materials, people, equipment, average cost, so you can create a template. That's where you can add your costs from Excel to Synchro. One of the simplest methods is copy-paste, and so you can just mark up a space and you can paste it to Synchro as a text. So from a very simple tool, you can go to much more complex tool. And now, let's assume that we are ready. The data is available. We know how to import it. And now we can go to planning. Planning and analysis, these two need to be discussed together, as this is a continuous synchronous process based on the data we analyze and also the data we visualize. We also take decisions on the schedule, and we need to eliminate the errors as we can easily spot them, or we make the things more realistic. So I will be using this very, very simple example where I have a very simple schedule. I operate on or work on the schedule. We create a structure of work division, and that's going to be my step one. And as Excel does not allow us to do this, if we have an update, so like the schedule submitted by subcontractor in Excel, if it is different, or if some more data is added on actual duration of works, you can update this information at Synchro without going back to the primary simple schedule. So these are the links, and we can develop this information. And now let's come back to a more complex model. So this is a 3D model. We have also copied costs, and on this preliminary simple stage you can visualize some things graphically, so you can show some cost options on a simple graph without doing anything, in fact, to generate this graph. To be able to speak about a 4D model, we need to assign resources and representing objects. In this case, we will assign this to individual kilometer sections. You don't have to do it manually, so having some data or creating some sets of data, and so withdrawing the data from the objects, you can automatically connect the geometrical information with the tasks to be completed, and that's how you can. So we have some assignments. And now how to calculate the duration of tasks, or how to make them more realistic. So at the very beginning, all of them take just 1 day, but more actual values will be calculated if we combine the efficiency and the volumes. So we need to define some rules how quickly can embankments be completed, or how quickly asphalt can be laid. If we change a type or duration of a task, and if this depends on some physical values, if we make a recalculation, so we will get more realistic duration, and we will be able also to compare different options if we have different rules and different efficiencies. By doing this, it will be possible to continuously visualize what is happening. Obviously, this model is very simple. This is just a road. But just wanted to show that by colors, you can say what is happening. Using colors, you can say what is happening and to which section those tasks belong. We have kilometer sections, we have color coding, depending on the type of tasks. And obviously, this is what you can see within the software, but the things can be also done, the animation can be more efficient within the software. And let's add one more puzzle to this. That's optimization. As all these preparation, analyzing, showing things, it needs to be done for some reasons, and in our minds we need to keep that this is for some reason. We want to do some things better, in a better way. We want to find some weaknesses. We want to find some opportunities for improvement. And how can these places be located? To optimize things, we need to find some gaps in the schedule, some linearities, some irregularities, something what stands out from others. And this data visualization, as you can see, That's how resources can be used. The simplest tool. In this schedule, I'm showing what is the life cycle of concrete after 2 days. So what can we read in this chart? It tells us that we have some peaks at some locations. So in that particular week, we are going to have extremely large volume. So we can try to find some kind of balance in resource management. And we will be able to avoid bigger problems on site, like stuck entrance to the site with a large number of tracks. And even more interesting for me is to analyze how we manage human resources. This chart will tell us that in that particular week, we have 16 teams working on site, and it might be that we only have 14 containers. So probably we need to change this schedule and make it a bit more flat, as we tend to have the usage sustainable, balanced, and continuous without humps. And the analysis can be carried out not only in the context of the entire area, but we can concentrate only on some sections, on some parts. So let me add one more element with small font, but that's also very important, that's sharing. We can use a connector, but as we are still in this maximum simplicity, I will use the Excel sheet. So if Sankra, if we know what we want to share, and if we have information on resources or tasks, we will export the 4D model to Excel sheet, and then this can be attached to Power BI, which is a free of charge application, and we can also do this like visualization like this, where you can show your schedule. We've got a filtering option available depending on what was uploaded to the system, and this can be showed to teams, or you can share it on a website. And this is a little bit more advanced products. You can show a chart of client value that's used for monitoring of progress on site. So these are actual costs, and you also have got information on actual duration of the task. You can also share this chart telling us how we use resources, material resources. By selecting one thing, we can see in that particular point in time what are the volumes, and you can compare those to the actual ones, and you can concentrate on one piece of resources. You can analyze the resources, human resources, which are linked to this. Coming back to this point, It is important to remember that so we need to use the same units of measure. So in the report, if we use or calculate like square meters, if we need to calculate to cubic meters, if we want to keep it consistent. But all these calculations can be done in Synchro. You can start some filters, and you will be using some scripts to make the calculations, and you can show them here. And let's now come back to this analysis of human resources.
We can display such things like indices of utilization and percentage of completion of the plan, 150% standard amount completed. And this also gives us some information about where we are and what is where we are. Here we already have a chart displaying use of individual machines. We can focus on one of them only and see how it is being used, compare what we had planned, what is the reality, and we can focus on a specific distance. And we can see, yes, this is how we were planning, the reality is different. You can compare the time of stoppages, outages, when we get information from the site about how long the engine was working. That may be sent by some sensors. For example, we can also introduce this information and compare what we had planned and how much work was registered in reality. Well, in blue we have the working time and red is outages, and here we have the location. Too much of the machine was used compared to the amount planned, but in reality it may mean that in the time schedule there was an error because this machine could have been used more intensely. So such things can be subject to analysis with the use of Power BI, and we can share it with team members on the teams. For example, of course, here we are coming out from 4D Synchro. We are going into other tools which can prove being very effective in communication with those who do not have access to this software which we have. And for example, we can use it on our web page and thus share it with our client. In this sharing, we have to ask ourselves what I want to show others, what I want to share, and what I want to analyze and to show. This is also a question up front. Well, we ask a similar question at the beginning. Well, what do I need for my 4D model? What information is needed? Here, if we want to share data from our 4D model via Power BI, we know what we want to display, what information will be needed for our visuals, so we prepare appropriate layout. That means we show this information in Synchro, we export this information to Excel, and Power BI is one of possible data sources. There may other data sources go in as well. If we have something what actually connects us to some data sources from the outside, it can be some ID machine or something like this. We will be able to create links and show what next, and publish, for example, on Teams, not actually advertising Teams here, no way, but it is something what has become very common now in remote work. So I think that everybody have been in touch with this tool, knowing its possibilities and limitations. Here I was talking about using Excel, but we can also get connected to our model in the cloud through a connector, so-called. But this is why I used Excel, because starting from Excel gives a possibility to better understand how our tables, matrices are structured. And then when we want to create some relationship among various data sources, then if we do it in export from Excel, we find it easier to learn this tool, and we are not actually overloaded up front with too much information. So here I have gone through the process of preparation. I was not mentioning standards, but they are necessary to later on enable operation. We are preparing our data, building our processes. We need to prepare our people. We need to prepare people who will be working with it so that they gain some competencies, they understand what they are part of, and we are testing all that. And, the more we do at the preparatory stage, the less surprise will hit us later on. At the stage of planning or creating the time schedule, the first step will be linking tasks to people who have 3D representation or do not. And we can also plan based on a 3D model with some external tools. And at the same time, planning, we analyze the sequence of the construction site, and we analyze our resources. Remember, time is one of the resources. We analyze costs, and then we will analyze progress at site compared to what we had planned. Planning and analyzing, we can keep visualizing it all the time. I mean, the time schedule and analysis alone. We share this information constantly with our colleagues and team members in order to optimize and improve this, because somebody may grasp details which we had not noticed. So that's why it is worthwhile including possibly most people in the process, and it's worthwhile doing it from the very beginning. I mean, plan already at designing stage rather than leaving it for the very end, because then it is more difficult to modify something. And when the content disappears, here we have a map of solutions which we will be facing. So preparation, we will be in touch with native formats, be it of our 3D models or time schedules if they come from the outside. When planning, we may stay in the synchro environment where we analyze and we visualize data. And here, of course, synchro control will be taking place. If we want to work on a cloud solution, we will be optimizing. That means making some decisions regarding our time schedule and modifying it just because we have grasped some problems. We can share all this. We can share it within synchro solutions, be it using freeware or synchro control or Excel. And also we can share through Office solutions. So here back to the very beginning. A little bit, we can see that the weight is distributed a bit differently. It is not, I mean, it shows the preparatory stage, but it is plan, analyze, visualize, and best prepare, analyze, and share. It would be clearly too long. So everybody who are people working at university or who are students are kindly encouraged to get registered at education.bentley.com platform, because it enables access to academic license of Synchro. And these things, I mean, this planning, model phase planning, can be started to be done on your own. And tomorrow I'll tell you a little bit more about it at the planner session, so you're kindly invited to join it. And now I intentionally left some time. If some questions arose, I will answer very gladly. Thank you, Daria. I checked on the chat. So far, there are no questions. If they appear, I will pass them on to you. So we will meet tomorrow during plenary session. So therefore, I will convey these questions. Thank you very much. So best regards to everybody at the studio and to all participants. Have a good day. Thank you.